All right, so there is one more method that I want to show you. This is kind of an optional method because it won't be on the AP test. Like you won't have to actually use the cylindrical shells method on the AP exam. They've eliminated it from the content. However, I think it's a useful one conceptually, but it also, there are times when knowing it might save you some work on the exam. So I'm going to show you it, and it's up to you how deeply you want to learn it. But I'm going to try something new here. So as part of my video, I'm going to play someone else's video, and it's going to be sped up. So let's think of if we're taking a cross section that looks like the one I have here in this picture, okay? And we're rotating it around a vertical axis, okay? A y-axis. And most of the time, what you would instinctively do if you're rotating it around the y-axis is convert it so that instead of y as a function of x, you have something where x is a function of y. However, the cylindrical shells circumnavigates that responsibility. You don't have to do that. So let's watch what's happening. Think of taking this thing and dividing it up into cross sections, and then think each of these cross section is going to be a cylindrical shell. Okay, that's what this video does a very good job of showing that I am completely incapable of doing. You are going to have a volume that's sort of like you can think of as a sum of those different cylindrical shells. So if you could come up with a way of making each cross section be the area of each of those cylindrical shells, you would have a volume of the piece that you're after. Okay, so what is the formula for the area of a cylinder? I think area is equal to 2 pi r L, right? If you have, if you, well, you can go back and look at that. That's like if you unroll a piece of paper, you can see that the circumference becomes the height of that rectangle. So what I want to do in this case is I want to think of, I'm going to make a bunch of different cylinders, and each cylinder is going to be an area. So in this particular case, I put all the information that you need on here so I can just get down to writing. I want to make an integral from x goes from 2.586 to 5.414 of, I'm going to put the 2 pi out here, times what's the radius of each one of these cylinders? Well, if I have this radius, it looks like it's going to be x. What's the height going to be? It looks like it's going to be y, which is negative x minus 4 squared plus 2 dx. And I'm not going to bother evaluating that, but that's a basic overview as to how the cylindrical shells method works, and it's a tool that you can use. The key, I think, is recognizing why is it better. Well, so if I draw a line that's perpendicular to the axis, if I'm rotating it, and it goes through more than one point of that graph, that creates a problem. Okay, it's not a problem if I have two different functions, right? If I have a y1 and a y2, it's okay to create a situation where I'm subtracting y1 for y2. However, if that line that's perpendicular to that shape goes through two different points of the same curve, that does become a problem. And now, yes, it's possible to turn this into two different functions, right? If you try to find the inverse function, you're going to get a square root, and you remember that the square root has the plus and the minus, but it's clumsy, and they'll never expect you to do that on the AP exam. So the one of the keys, I think, is to, if you draw a line perpendicular to the axis that you're revolving or rotating a shape around, if it goes through more than one point on the same function, then you're going to be thinking cylindrical shells. That's the way that's going to get you to your answer the quickest. Okay, hopefully that is helpful.